Okay, number 7. We know, or we're given that the point 58 is on a graph. And we don't know the equation or anything, but they're giving us the symbolic notation y equals f of x. And in terms of notation, y and f of x are the same thing. So we have some y equal some function, and we know that this 0.58 is on there. We want to know which of the following must be on the graph of y equals negative f of x. Okay, so what you need to understand from this notation is that f of x is equal to y. And the fact that they put a negative out front means we want to make y negative or change the y value, give it the opposite sign. So when we take this ordered pair 5, 8 that we know is on the graph, 5 is the x value, 8 is the y value. We're going to change the sign on the y value only. That's the only thing that we're changing. So we're making this negative. And that being the case, we know that the ordered pair 5, negative 8 would also be on the new graph. So just following the notation, that's the conclusion that we can draw. Okay, so number 8, we want to graph the function. We're going to use the techniques of shifting, compressing, stretching, and or reflecting. We're going to start with the basic graph of the function shown to the right, and then we're going to find the domain and the range of the function. Okay, so in the parent functions, if I go to that one, we have this radical function. You are given the standard domain and range, and if we have any shifts or translations, that will also affect our domain and range accordingly. So we will use any translations to affect our new domain and range. For the first part, the graph, the original function is square root of x. We want to graph the square root of x minus 4. Notice the minus 4 is under the square root. That has the same position as in the function notation of h in the grouping symbol with x. So that we're seeing a minus 4. And when I see the negative with that, I know that this will shift my graph right. Okay, so we're going to go 4 units to the right. So which graph shows this one going 4 units to the right? If we look at this scale, this one went down, this one went up, so no, those are not it. This one went left. This is the only one that went right. It looks like 2, but if you count the tick marks, and this one is at 12, there's 1, 2, 3, 4, 5, 6 tick marks, and the 6th one is 12. So they want you to understand that this is counting by 2. So there's 2, 4, 6, 8, 10, 12. And with that being the case, if that's counting by 2s, then that's definitely getting shifted right 4 units. So C is the answer choice we want. And then when we move down, we're going to be looking at domain. So I want to find the domain of this function here. So the original domain, let's go back. The original domain was from 0 to infinity. When we move this right 4 units, we're now starting on 4. So instead of starting at 0, we're going to start at 4, and it's still going toward infinity. So all we're doing with our domain is taking it and matching it with our graph. So instead of starting at 0, we're now starting at 4. So we're just going to shift our domain over 4 units, the same as our graph did. So we're going to go from 4 to infinity. Same starting endpoint with a bracket, end with a parenthesis. And then our range. So our range was from 0 to infinity because it's on the x-axis, and that's where y is 0, and it's going upward. And when we shifted our graph to the right, that did not change the vertical direction at all. We didn't go up or down. We only went right. So our graph is still starting on that x-axis where y is 0, and going up toward infinity. So in this case, our range has not changed. It will still be 0 to infinity.